I found this circuit pure experimentally. It's an audio amplifier connected to a non-stable multivibrator circuit. So the output from the frequency that we put in here goes to the non-stable multivibrator, but we have a bridge, one capacitor in the generator by a transistor, a PNP transistor. This capacitor is bridged by this BC557 transistor. So it means that the frequency changes when the transistor gets into conduction, and when the transistor is completely in conduction, the oscillator will stop. And that's why I call this circuit that in this way a blinking LED stops when the frequency gets too high. And it needs some elaboration, but take your time. When you don't have enough time to figure it all out, perhaps this is not a good project. Here we set the frequency where the circuit blocks. And in this case I've set the whole circuit to a frequency where I can watch over the grid frequency from approximately 50 Hz in the Netherlands. So here's my audio generator, here's my counter, here's my scope, and what I'm gonna do now is in fact set the amplification from the first stage from the transistor, and that drives this transistor here, that's the PNP transistor, into saturation. It blocks the capacitor and the oscillator stops. And I found that it is very critical and that it works very precise, with a precision from approximately 2 up to 3 Hz. So that's quite precise. And that's the reason why I published this circuit. Perhaps someone can use this circuit. I'm going to change now the block frequency. And here you see the LED that is going to flicker 56 Hertz. Now I change that potentiometer from 1K, and on a certain moment the LED stops. Now it stops, and it's approximately 52 Hertz on the generator, 56 Hertz on the counter. But what I'm going to do now is to change the generator frequency. I'm going down now to 48 Hertz and further back to a lower frequency, 42 Hertz. And now I raise the frequency again, and I don't have a precision sine wave generator, but here you can see that on a certain frequency the LED stops, the blinking LED stops. So here it stops at 46 Hertz. And you can set this potentiometer, and by setting this potentiometer you can set the block frequency. I don't know how it works, sorry. I only found that it works. Here you see how the A-stabile multivibrator is influenced by the frequency. And you can see that it jumps up and down, so this means that the LED lights and doesn't light in a certain pattern. And when I make the frequency too high, you will see that it stops. And I found experimentally that the whole circuit works between 50 Hz approximately and approximately 1000 Hz or so. Perhaps even 2000 Hz or 6000 Hz. You can test that individually where you want to use this circuit.